Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, electricity. So today we are in the session number 2. This is the syllabus, fifth chapter for the syllabus for test 2. We have synopsis 1 and 2. We already covered some part of the synopsis 1. So today we are going to almost very close to the synopsis 2. Again, we get 2 more sessions before the examination. We can cover the syllabus as per the exam, right? But before that, before going for today's session, let us recall what we learned in the earlier session. So as you remember, we learned about the history of electricity. I explained to you about what is the prehistory of electricity. When the electricity, the word is introduced by the great Greek philosopher Thales, right? Thales introduced the word electricity because its properties observed 2600 years back, when one stone called amber rubbed with the hair, animal hair called fur. Both of the bodies are acquiring the charges. Both of the bodies are getting opposite charges. Such phenomena is also called electrification. We discussed in the last class, last topic. So whenever two bodies rub like that by the friction, even when you are rubbing by friction also, you get the heat. They get the charge. Even when you are combing the dry air, we can find that the comb will get electric charge and attract the papers, which already seen in the video also last class, right? So we learn about basic information about the history of the electricity, and we introduce some terms also, right? So we'll continue from same to know more about the charges. What are, there are 2 types of charges are named. One is positive charge, other is negative charge, right? So we have seen what is electric charge, and electric charge is measured in units called coulomb. Coulomb is the unit for electric charge, named after the scientist name, that is Coulomb, right? And after knowing about the charge, we learn about what are the conductors, what are the insulators, and what are the semiconductors. So there are substances, there are materials, right, which allows the electricity to pass through them, are called conductors. Like metals, all the metals are conductors. Human body also conductor of electricity. Graphite is a conductor. Okay. Then opposite to that, substances which does not allow the light to pass, electricity to pass through them. They does not allow, like wood, rubber, plastic, diamond. They comes under the insulators, which does not allow electricity to pass through them. There are another type is there between these two, semiconductors. Semi means partly. So substances which allows the charge to pass through them partly or partially are called semiconductors. So germanium, silicon. So this is one very huge branch of physics is there called electronics. So electronics is completely deals with the semiconductors, right? So we have seen up to here. Then we introduce what is electrification. So generally I told that every body is neutral in nature because it contains equal number of positive charges, equal number of negative charges. When the both are equal, the body is said to be neutral. When it loses either electron or proton or positive or negative, it will get charged by rubbing or by various methods are there. The process of giving charge to a body is called electrification, right? The process or the phenomena or the method of giving a charge to a body. If you give the charge by rubbing, that is called friction, charging by friction. Already I told that time itself, 2600 years back only, the Greek philosopher tried many combinations. He observed not decided with single one. He rubbed first with the fur with the umber, then he taken the glass rod with the silk cloth, ebonite rod with the silk cloth, cat skin with iron rod. So many possible ways they are rubbed, and find that when the two bodies are rubbed, they are getting charged by friction. That is process called frictional electrification, or simply electrification, right? So there are so many examples are given here for the electrification. You can see a perpex and cyclic plastic material rod, on the other hand, becomes positive charge if rubbed with the woolen cloth. When the perspex is a different kind of plastic. So when rubbed with the woolen cloth, get the positive charge. In this case, the electrons are transferred from perspex to cloth to the rod, right? Negatively charged. So cloth becomes negative charge. Whichever is getting electron, receiving electron, will get negative charge. Whichever is giving electron, will get the positive charge. Right? So like that, there are so many examples are given here. Ebonite rod with the cat skin. Third one example, see. So some electron transfer from one to another, and they'll get the charges. Like that, this method of giving charge is called friction. Charging by friction. Any two bodies rubbed with each other, they'll get the charge. Such process is called a friction by charging by friction. Okay. Any example you can write. Any two combinations you can observe. Okay. Then, so apart from the friction, there are some more methods are there. Conduction is also a method, right? Conduction. If your body is charged by contact with another charged body, suppose you are taken positive charged body, we kept another charging other body here, right? Then the process is called charging by conduction. By keeping two charged bodies, one to neighbor to another, right? So one is charged body, other is neutral body. So there is no charge, no charge. Suppose we kept one body near charged body, or one negative charged body, one neutral body. What happened? The charge will passes because of the conduction process. There is a air molecules are there surrounded. So what happened? The charge from here moves through the air particles, that is called cloud, and the body get the opposite charge. So that is by conduction method. When you are touching each other, by touching them also, we can transfer the charge, just like magnetism. You might have seen magnet, right? When the one magnetic pole is placed near the magnetic material, by direct contact, we can get the charging. Direct contact. So that is the body's conduction. In this process, the body acquires same charge, and the change and total change is shared by the two bodies. So same charge, there are same charges, not opposite, because same charge is passed. If you want to give the same charge to the body, one charged body should place near the neutral body. So negative body gives negative, positive body positive. Next one is induction. Conduction is direct contact. Induction is without direct contact, influence. For example, take one magnet, place iron somewhere near to the magnet. Without direct contact also, after some time, iron become magnet. Similarly, charge also. See, if your body is charged by presence of another charged body without contact, then the process is called charging by induction. Charging by friction, charging by conduction, charging by induction. Okay. Charging by induction is temporary only. As long as the charged body is there, other body will act as charged body. If you remove that, it loses the charge. Induction is temporary. As long as body is there, it will become. Okay. Now, charge can be passed from one object to another object, but cannot be lost. Every electron has charge. See, the charge of electron is given by minus charge. Electron is negative charge, so 1.6 into 10 power 19 coulomb. Whereas for proton, that is plus 1.6 into 10 power minus 19 coulombs. Right. So the charge of electron, you can write like this: E minus is equal to or minus 1.6 into 10 power minus 19 coulomb. Whereas proton plus is equal to plus 1.6 into 10 power minus 19 coulomb. This is a charge of electron and proton. Charge is same, but thing is one is negative, one is positive. Right? So charge can be neither created nor destroyed. But the charge acquired by any body is the integral multiple of n into E. Number of times. How much charge you are giving, you will get the n into E. N is the number of charges, how much you are giving. And charge of each electron. Right? So how much charge is acquired, you can calculate by using the formula n into E. How many number of electrons are there? How much charge is there? N number. That n you have to put, and charge of each is 1.6 into 10 power minus 19. N into 1.6 10 power 19, you get the how much charge is acquired around the body. See here, diagrams are given. Charge by friction, charge by conduction, charge by induction. So friction is rubbing two bodies. Conduction is placing one charged body and one neutral body. Contact with each other. Induction is taking one charged body and neutral body without contact also they can charge it. So like that, there are three methods for electrification. There are three methods for giving charge to a body. Right? Clear? So three are friction, conduction, and induction. Clear? Note on that. So you can write it. So electrification. So electrification is nothing but giving charge. Right? So electrification number one is friction. That is charging by friction. Second method is conduction by direct contact. And third one is induction. So like that, there are three methods for giving charge to a body. We can give charge to a body by these three methods. Okay. Clear? So there are diagrams also given how they are converted from one form to another form. You can note that. Right? Now we'll move to the next one. Right? Next, after knowing about the electrification and charging, there is one law is there, very important. Between two charged bodies, the force, suppose I told you, like charges repulse, unlike charges attracts each other, correct? Based on that, there is a law proposed by Coulomb, which is called law of electric forces. Suppose there is a positive body is there is a negative is there. They are separated by distance d. Then what is the force acting between them? So it is actually because positive negative is there, they're attracting force. Suppose there are both are positive are there or both are negative, but still force acts on them. But that is repulsive force. Repulsive, or you can say distance, they measure as R, not D. Right? Then the force between the two charged bodies is given by the law called Coulomb's inverse square law, or simply Coulomb's law. So see, the first statement is the force between the bodies is directly proportional to product of the charges. Suppose charge is Q1, Q2. Q1 into Q2 is the total force acting on that. And it is inversely proportional to square of the distance. Distance increases, force decreases. Right? Distance increases, force decreases. Distance decreases, force increases. That is second statement. By combining these two, we got common formula. F is equal to K. K is the constant taken here. F is equal to K into Q1, Q2 by R square, or simply K is value generally 1. So you can write Q1, Q2 by R square is the formula called Coulomb's law. Coulomb's law. Right? The K value also given, see, 9 into 10 power 9 in vacuum or free space. So in case of vacuum or free space between the two charges, we can take 9 into 10 power 9. If any other, we can take one only. Different mediums or different values. Okay. So according to the new Coulomb's inverse square law, the force between two charged bodies separated by a distance R is directly proportional to product of their charges and inversely proportional to square of the distance between them. So from that we got the first equation, second equation, combining them we get the common equation. equation 3. Okay. This is called Coulomb's law, which is helpful for you in the coming chapters. So this is about the law of electric forces. Then to identify the charge, whether suppose you have one body in your hand, suppose I have pen. What kind of charge pen have after rubbing with some cloth? What is the charge of pen? If you want to test, you can test with a device called electroscope. So an electroscope is an instrument for detecting the presence of very weak electric charges and for determining whether the charge is positive or negative. We cannot go for the high charges. High charges, there are some devices are there. Small charges can be detected by this electroscope. What is the, whether charge is present or not? If present, whether it is positive or negative. To know that, we can use the electroscope is a device. Electroscope is a device used to check the presence and kind of charge. If suppose charges are there, then neutral only, no problem. If charge is there, there is a attraction or repulsion can be seen. So in that, the first kind of electroscope is pith ball electroscope. So simple, it is a ball made up of cork. You can see cork, you know the cork. A cork ball also there, a small cork suspended by a thread to the stand. Suppose you bring one positive charge, see here. Positive charge are brought here. Whether it is attracting or repelling. Based on that, you can identify the ball is having the body is either positive charge or negative charge. See, we are given the positive charge for the ball. Then positive charge in body is there. So what happened? Ball is repelling here. So you get negative charge to the ball and positive charge is the attracting. First, you have to give charge for the pith ball. Then you have to identify the charge of other body. So such a device used to measure the presence and kind of charges, pith ball electroscope or simply electroscope. So before going for the further explanation, let me show you one video on basics of the electricity so that you can know more clarity about this. Okay.
Hello friends. What do we need to run our television set, refrigerator, DVD players, video games, computer and fax machines? Yes, it is electricity. Electricity has always been around because it naturally exists. Lightning, for instance, is simply a flow of electrons between the ground and the clouds. Objectives. At the end of this lesson, you will be able to define electricity, establish the relation between electric current and charges, identify the two types of electricity, define conductors and insulators. How do you study in the late evening? Of course, you light up your room using an electric bulb. Have you ever wondered what causes the bulb or the tube to light up? They need electricity to light up. Electricity passes through the wires and reaches the filament of the bulb, heating it up to glow. When we comb our hair with a plastic comb and take it near the small pieces of paper, the paper pieces are attracted toward the comb. We then say that the comb is charged with electricity. This was first noticed by a Greek man named Thales over 2,500 years ago. Thales found that amber attracted tiny feathers after it was rubbed with silk cloth. This was due to static electricity. The origin of the word electricity comes from the term electron. Let us perform an activity to understand positive and negative charges. Take an ebonite rod and rub it with a piece of woolen cloth. Now suspend the rod by tying a thread through its middle. Now charge another ebonite rod in the same way and bring it close to the suspended rod. What do you notice? The suspended rod moves away from the second one. Now take a glass rod and rub it with a silk cloth. Bring this glass rod close to the charged suspended ebonite rod. What do you observe now? The suspended ebonite rod comes closer to the glass rod. The charges
It is just
produced
like
in
a
the
electroscope
ebonite
only.
and the glass is different in nature. These two kinds of charges are called positive and negative charges. The positive charge is shown by the plus sign and the negative by the minus sign. Merely as a convention, charge on a glass rod rubbed with silk is taken as positive, and that of ebonite rod rubbed with woolen cloth is taken as negative. From the earlier activity we can conclude that like charges repel each other and unlike charges attract each other. Fill in the blanks. We have just studied about electric charges and the forces they exert on one another. We have learnt there are two types of charges, positive and negative. When charges transfer from one body to the other,
Now we'll get
the bodies are said to be charged. The moving or flowing charges produce an electric current. An electric current consists of a movement of negative charges, that is, electrons. The flow of electrons gives us electricity. Electric current is measured by ammeter. Dry cell battery used in a torch or transistor radio is a source of electric current. Every battery has two terminals marked plus and minus. When a metallic wire connects these two terminals, the electrons resulted from chemical reaction start flowing through the wire, constituting an electric current. These electrons flow from the negative to positive terminal. Thus, a cell is a simple device in which chemical energy is changed into electric energy. Some materials allow electric current to pass through them, others do not. The materials that allow electric current
already
to
seen
pass through them
conductors,
are
semiconductors.
called conductors. Iron, copper, brass, aluminium, silver, gold, graphite, etc. are the conductors of electricity. The materials through which electric current doesn't flow are called insulators. Insulators are also known as non-conductors of electricity. Paper, wood, plastic, cloth, eraser, rubber are the insulators. Pencil lead is made of graphite. It is a form of carbon. It is non-metal, but it is a conductor of electricity. It can be tested whether a given material is a conductor of electricity or not. The given material between the free ends of wires in an electric circuit face the given material between the free ends of wires in an electric circuit. Bring the free ends of the two wires close. Now let them touch each other. If the bulb glows, the material is electrically conducting, otherwise it is an insulator. Both conductors and insulators are important while using electricity. The conductors like copper or other metallic wires are used for electric supply, but at the same time, these metallic wires are coated by insulating materials like plastic or rubber for safety. Summary. Let us summarize what we have learned.
Everything is clear.
Electricity is a
What we learned
form
till
of
now.
energy.
Right.
Charges always occur together. Like charges repel,
Unlike charges attracts. So, complete basics about the electricity till the conductors, insulators and all. Then we learn about even what is the law of electricity, right? Law of electricity is nothing but Coulomb's law, which is given by F is equal to Q1, Q2 by R square. Then we have discussed what is electroscope, that is pith ball electroscope, to identify the presence of charge and kind of charge. If charge is there, whether it is positive or negative. If charge is not there, there is no charge, neutral. So for that, what we use? Electroscope. Electroscope is a device used to measure the. In that again, there is a separate instrument is given called gold leaf electroscope. Gold leaf. So it gold is a very sensitive metal. So they use the gold here in the place to attract or repel. See here. These gold leaves there. Two gold leaves are suspended to a rod, say. So metal disc, rubber stopper, metal rod, gold leaves and wooden base. So this setup is done. Initially, what we are doing, we are passing the charge to gold leaves through the metal disc. We are giving some positive charge to the gold leaves. When positive charge are given, gold leaves are repelled. You can see the repulsion of the gold leaves. Then we brought some other material like glass rod or silk cloth or ebonite rod near the glass bottle. We can find whether it attracts. It attracts means that is negative charge. If it is repulsed means it is a positive charge. Like that, you can identify the nature of charge because the pith ball is completely open. So air may affect it, but this is completely closed. So you can get the exact charge and exact strength also. So gold leaf electroscope consists of two gold leaves. It's very costly, so it is not used. Fixed to the lower end of the brass rod, and that they are held to parallel to each other. This brass rod passes through an insulating cork. This is cork, single hole cork. Right? Cork says ebonite fitted on the top of the glass vessel. At the upper end of the rod, there is a brass disc. This is brass disc. When the gold leaf electroscope is uncharged, the gold leaves remains collapsed, remains parallel. In charge by contact, the gold leaves receives the same kind of charge on the charging body. The gold leaves are being similar charge repulse each other and therefore diverges. They remains diverged even after charge rod is removed. So whether the gold leaves are diverged or converged, attracted, based on that, we can identify the charge of the other body. From outside we are seeing. Right? So such kind of device used to measure the presence and kind of charge. The sensitive device is our gold leaf electroscope. So there are two types of electroscopes: pith ball electroscope, gold leaf electroscope. Pith ball is because it is opened. Maybe there may be air effect, so we cannot get accurate. So that is the reason the device is the gold leaf electroscope. That this also, because gold is so expensive, this is not generally used in the laboratories nowadays. Right? Now lightning. Thunder. Lightning and thunder occurs in the nature because of electricity only. When the two clouds they collide with each other due to transfer of electric charges, lighting and sound will come. Lighting and sound. Sound is the thunder, lightning is the electricity. So nature's phenomena. The nature's phenomena of producing of light is lightning. Right? So lightning occurs when the charges jumps from one cloud to another cloud or from cloud object to earth. Either is from cloud to cloud or cloud to earth also. So due to the jumping of charges, transfer of charges, the lightning can be seen in the nature, especially during the rainy seasons and all. So lightning is gigantic electric discharge occurring between the two charged clouds or between the clouds and the earth. It was American inventor Benjamin Franklin, very famous, who showed that lightning is with static electricity formed by the friction between the droplets and particles, ice crystals in the rain cloud. So as the ice crystals and water droplets collides, they transfer the electric charges and gives out the lightning for us. When the two clouds collides, sound also will come. That is called thunder. So everything is the nature's process, right? However, building can be protected from the such damage. So generally, see, during the lightning, we'll have one antenna over the houses to protect from the lightning. So there are so many precautions you have to take for lightning that will come across in a different chapter. Okay, so this is about the gold leaf electroscope and lightning phenomena, which is the nature's phenomena of producing the light or effect of light. So that is about our first synopsis. Now you can come to the second. See here how the thunder, when during the lightning, how the charges comes and fall in the house. So to protect us, we'll have the one antenna over the house which receives the total charge, total lightning, and we are safe. Okay. So this entirely thing comes under the synopsis 1. So when you meet in the next class, that is on Tuesday, so we'll have the synopsis 2 also, which is our syllabus for test 5, where we'll discuss about what are the sources of electric current. Means from where we can get the current. Current can be obtained from battery, transformer, generator, inverter, and many more. Dust, water, wind, heat, coal, petrol, everywhere you can produce the current, even garbage. So there are so many sources are there to produce the current, but mainly cell batteries. There are some small sources are there. There are some large sources are there. So as per our requirement, we'll use the source of electricity. At our home, it requires around 220 volts. If you go to some factories, 700 volts are required. If you go to some big apartments, more required. So as per our requirement, you can produce the current by various methods. All these are comes under the sources of electricity, which we'll discuss in deep in the next class. Okay. So this is different types of cells are there to produce the current. Suppose some are used in remotes and watches. Some batteries will use the radios, big one. Some cells will use the 2-wheelers, 4-wheelers also will use the batteries. And some industries they'll use. Some DJ will use the different batteries. So different types of batteries as per requirement. We can see there. Leclanche's batteries, dry cells, batteries. So many are there. So many you can see in the right. Right? So many we can see. So many types of batteries you can see during the. So what we learned here today? Today we completed the total synopsis 1 till now. Okay. Where we learn about what is electricity, starting which we discussed in the first class. And then, so there are types that are there. That is electrification, how we are giving the charges. Electrification. So electrification types we are discussed. There are electrification by friction, electrification by conduction, electrification by induction, we learned. All the methods. Then electroscopes we have seen. Electroscope. There are 2 types of electroscope again. Pith ball and gold leaf. Right? Gold leaf electroscope in details. Then already we see the conductors. How the conductors conduct electricity. Insulators, which does not allow electricity. And semiconductors we discuss. Right? In details we discuss about this also. Then we have seen what is lightning. So this Coulomb's law. Right? Coulomb's law. And also we have seen what is the lightning. How lightning occurs in the nature. All these are the very important concepts in the nature as well as in the our regular. So what next we will discuss, introduce about the sources. What are the various sources of from where we can get the electricity. You can collect the information before start of the class also. Right? That's why I give you the homework for that only. So you can collect, you can have so many idea where you can see the electricity. From where we can get electricity. Starting from cell, battery and batteries, big batteries like your vehicle batteries and many more are there. Okay. So that's why I give name some source of electricity in your own. You collect before the Tuesday class. That is our today's task, home task. Okay, write down the question and go for the home task here. Right? So that's all for today. So thank you all of you. Good to see. Go more number of branches. KTS Jogipet, Indresham, Pooja Reddy, Ramnagar branch, Swarup Nagar, Falaknama, Gopal Nagar. Again, one more Indresham and Vaishali 6th. Right? So thank you all of you. Have a wonderful day. Thank you.